So those who are online, are able to hear me?
Yes, sir.
Okay. So we shall get started. So listen. So last class we did one problem that is based on an object moving under the influence of gravity. Remember, there was a person who threw a ball from a multi-storied building, went up and came down. No. So what we will do is we'll continue with the next one. A ball is thrown up, is caught by the thrower after 4 seconds. So there is a person who is throwing the ball upwards and it is coming back to the person's hand in 4 seconds. Right? It is coming back in 4 seconds. How high did the ball go and with what velocity was it thrown? So question number 1 is, what is the maximum height attained by the ball? Second is, what is the initial velocity which was imparted to it? And how far was it below the highest point 3 seconds after it was thrown? So, what is the value of h after 3 seconds? But from where? Not from the bottom, but from highest point. I hope you're able to understand this question, right? So when you throw it upwards, if I take this to be A, let's say the object is going to a maximum height, let's say at point B, right? Now, to calculate H max, we already have a mathematical equation. H max is equal to U square divided by 2G, right? But the problem here is we don't know how much time it took for the object to go from A to B. I'm sorry. The problem is we don't know with what initial velocity was it projected upwards, right? Now the next question is, since the time of flight, right? Since the time of flight is equal to 2 seconds, can I say that the time of ascent is equal, time of flight is 4 seconds. Can I say that the time of ascent is 2 seconds? Because when the object is traveling under the influence of gravity without any air resistance, the time of ascent is equal to the time of descent. So time of ascent is 2 seconds. So using this, what I will do is, I will use the formula V is equal to U plus AT. So this is for which journey? This is for the journey A to B. Okay. So when it goes from A to B at point B, the object is coming to rest. And if I take the initial velocity to be U, it is in the upward direction. What is the acceleration under which it is moving? It is moving under the acceleration of gravity, acceleration due to gravity, right? So when G is in downward direction, U is in upward direction, G is considered to be negative. So minus G into T, which implies U is equal to GT. So G is how much? 9.8 into time is 2. It is going to be 19.6 meter per second. So this is the initial velocity with which it was projected upwards. So it is 19.6 meter per second. Now, since you know this value, take this and substitute it here. Right? When you substitute it, then H max will come out to be equal to U square is 19.6 into 19.6 divided by 2 into G value is 9.8. So 9.8 into 2 is 19.6. So the answer will be 19.6 meter. So the maximum height traveled by the particle is 19.6 meter. Now, the question is, The third part of the question is, how far was it below the highest point? So if I take this to be the reference line, below the highest point, how far was it at which second? After 3 seconds, right? After 3 seconds, since it was thrown. One thing we understood is it takes 2 seconds to go to the top, right? And it takes 2 seconds to come to the bottom. One common mistake that happens is, since we told 2 seconds upwards, 2 seconds downwards, we think that 1 second is exactly half of 2, and we think it was exactly at half of the maximum height. But it is not the answer. Listen to what I'm telling you. So we are telling 2 seconds to go upwards, no. So how will you get this 3 after this 2 seconds? 2 seconds upward, 1 second downward. So what we think is, since the total time taken the downward journey is 2 seconds, so out of which 1 is going to be half of it. So what we think is, after the 3rd second, it is exactly at the midpoint of the total journey, but that is not the answer. Can you tell me why is it so? That would have been the answer had the object moved with uniform velocity. What do you mean by uniform velocity? It does not experience any acceleration. But what is happening here? The object is accelerating, meaning when it is going upwards, its speed will tend to decrease, whereas when it is coming down, it will try to come faster. So in 1 second, it will not be exactly at half, it might be greater than that also, because it is gravity supporting it. Are you able to understand? Right? So what you're supposed to do is, since you know the time here to be 2 seconds, we'll try to calculate how much distance the object has traveled in the next 1 second. So for that, what I will do is, I'll apply the formula S is equal to ut plus half at square for the journey from B to C. Right? So what will be the displacement that we don't know? When the object is traveling in the downward direction at point B, it is going to take the initial velocity. What is the initial velocity at that point? 0. What about the acceleration? It is half into acceleration is minus 9.8. Why minus? Because downward is considered to be minus into t square, which is going to be 1 square. Answer will be minus 4.9 meter. So if you observe, 4.9 is not exactly half of 19.6. Are you able to understand? So what you should do is, if you take this to be 4.9, what is the maximum height that you got? 19.6. Out of 19.6, you should remove. Out of 19.6, we should remove 4.9. Then how much will the answer be? How much is it? So 16 minus 9, you will get 7. 18 minus 4, you get 14.7 meter from the ground, right? 14.7 meter from the ground. Whereas the question is all about how far is it from the highest point. So from highest point, the answer is still 4.9 only. So if they ask the question to be from the ground, then you should report it as 14.7. So be careful whenever there is a question based on distance that is being asked. We should always ask a question of with respect to which point. So can we conclude it again? So what is the answer for this question? Is it 4.9 or 14.7? 4.9, because they asked with respect to the top. Is that clear? So make a note of this. That's right. Shall we proceed? Those who are online, shall we proceed?
1 minute, sir.
Okay.
Done, sir. Done, sir.
Yeah. Okay. This. The next question is, two balls are thrown simultaneously. A vertically upwards with a speed of 20 meters per second from the ground, and B vertically downward from the height of 40 meter with the same speed along the same line of motion. At what points do the two balls collide? So if you take the ground, okay, I have an important call. Just hello. So could you crack it? Number trying to analyze the situation. Your ball மேல போடு அவன் கீழ போடுவான். சரி. See, two balls are thrown. See, had there been a possibility of calculating with stopwatch, எல்லாமே few seconds ல இருக்கும். If it is at least some time where you can observe things, நான் பண்ணியே காட்டியிருப்பேன். Like what you're doing is actually right procedure of learning. But unfortunately, answer la வந்து 2 second, 3 second ஒரு stopwatchல calculate பண்றது கஷ்டம். டக் ஆன் பண்ற கேப்லயே டக்குன்னு முடிஞ்சிடும். So it will be difficult. But yeah, we'll see. So there is a ball A which is thrown vertically upwards with a speed of 20 meter per second. So remember, A is traveling against gravity. Okay, so it is decelerating. Similarly, B is vertically thrown downwards from a height of 40 meter. So B is thrown vertically downwards from a height of 40 meter. So 40 meter with the same speed. So this is also thrown with the same speed of 20 meter per second. Now the question is, so one more important point is, and along the same line of motion. So they both are moving along the same line, right? At what points do the two balls collide? Right, where do they collide? Let's say they collide at this point. Let me call it as C. Okay, so this height, if I call it as h dash, then how much will this height be? It will be h minus h dash. Right. So one thing that we need to understand is the time taken by the object B to travel distance h dash and the time taken by the object A to travel the distance of h minus h dash is the same. Because they both need to collide means it should happen at the same instant. Right. So time taken for upward and downward journey is the same. Right. So what I will do is I'll apply S is equal to ut plus half at square. So if I apply it for object B, I'm still sticking to the fact that anything in the upward direction is, any vector in the upward direction is positive, any vector in the downward direction is negative. Okay. So when I take the object to be traveling in the downward direction, so what is the displacement of the object? H dash is equal to, but what is the correction I need to do? It is minus h dash. So minus h dash is equal to u is minus 20 into t plus half into minus. So in this problem, oh, they told G to be taken as 9.8. Okay. So I'll take 10 to be for a simpler aspect. Reason here you have 40, 20, everything. So I'll take it as 10. So 10 times t square. Am I clear with this? Okay. So here what is going to happen is minus will get cancelled. So h dash is equal to 20t plus 5t square. Let me take this as equation number 1. Next, if I apply S is equal to ut plus half at square for the object A, then how should I solve? Remember, h is 40. So 40 minus h dash, it is positive because upward journey. So 40 minus h dash is equal to 20 into t plus half into, okay, minus 10 into t square. Okay, which is going to be minus 5 t square. Am I right? So it is going to be 40 minus h dash is equal to 20t minus 5t square. Let this be equation number 2. Now tell me one thing. If I want to eliminate that 5t square, what can I do? I can add these two equations. When I add, plus 5t square and minus 5t square will get cancelled. Right. So when I add it, observe 40 minus h dash plus h dash is equal to 20t minus 5t square plus 20t plus 5t square. 20t minus 5t square plus 20t plus 5t square. So 5t square and 5t square are gone. H dash and h dash are also gone. So 40 will be equal to 40t. So t is equal to 1 second. So they exactly meet after 1 second. Right? So when they meet after 1 second, take that one and put it there in any one of the equation, you will get the value for h dash. So when you substitute, when I take h dash is equal to 20t plus 5t square, when I take h dash is equal to 20t plus 5t square, when I put t is equal to 1 here, h dash will be equal to 20 plus 5, which will be 25 meter. Meaning, out of 40 meter, object B has covered 25 meter, meaning it has covered more than half the distance. So out of 40, exactly the half distance is supposed to be 20, but it has covered 25. What is the meaning of it? It is traveling faster compared to the object from the bottom because the downward journey is acceleration, upward journey is retardation. Are you able to understand? So they both are going to meet at a distance of 25 meter from the top or 15 meter from the bottom. You can report both the answers. So if you just write 25 meter and leave, your answer is wrong. I'm repeating it again. Whenever they say at what point, you need to be clear with the reference point. How will you report the answer? Either at 25 meter from the highest point or 15 meter from the bottommost point. Clear? So make a note. You're done copying. You didn't copy from next page. Oh, you wrote it. Okay. Done. Can we do one more problem based on this concept? Yeah, we'll go with one more problem.
Sir, can you show the next page?
Yeah.
Yeah, yes, sir. Yeah, okay, sir.
So one last problem. So next one. A stone falls from a cliff and travels 24.5 meter in the last second before it reaches the ground at the foot of the cliff. find the height of the cliff. So let's say this is the bottom. So there is a stone that falls from a height h, right? At this point, let's say from here to here, it is taking 1 second. In this 1 second, it has covered a distance of 24.5 meter. Now the question is, find the height of the cliff. So how to do this? Okay, but that is not going to be a constant value. No? Where will you take it as 24.5 meter per second? It is average value. It is not the exact value at the second point. I don't know what is the velocity at that point. So let's say it is taking a total time of t. Can I say this distance is covered by the object in t minus 1 seconds? So if I take the total time of the journey to be small t, 1 second is gone here, t minus 1 second is covered here. So the height is going to be h. So how much is this height then? H minus 24.5. Right. So can you calculate what is going to be the velocity at this point? So when I use v square minus u square is equal to 2as. Right. Then what will I get? V square is what we need to find, minus u square is 0. I'm talking about the journey between A to B. Am I clear with this? So v square minus 0 square is equal to 2 into g value is, I'll take it as 10. So minus 10 into displacement is minus of h minus 24.5. Am I right? So v square is equal to 2 into, this is going to be 10, that is 20 into h minus 24.5. So this is v square. Minus of minus will become plus. V square can't be negative now. Simple. So v square is equal to 20 into h minus 24.5. Now this will be the initial velocity for the next part of the journey. Right. So v is equal to square root of 20 into h minus 24.5 meter per second. Makes sense? Right? Now, the next point is, listen. So the next one, what is the equation we got? V is equal to root of 20 of h minus 24.5 meter per second. So this is going to be the velocity for the next part of the journey between B to C. Between B to C, it is taking 1 second. And how much is the distance traveled? 24.5. So applying S is equal to ut plus half at square between B to C. What will we get? So 24.5 is equal to u is square root of 20 into h minus 24.5 into time is 1 second plus half into minus 10 into 1 square. Am I clear with this? So this will go 5 times. So this can come to the other side. So 24.5 plus 5 is going to be 29.5 is equal to square root of 20 into h minus 24.5. So square on both the sides. 29.5 into 29.5 is equal to 20 into h minus 24.5. If you solve this, you will get the value of h. But did you understand the approach? So what did we do? We calculated what is the velocity for the last second of the journey by using which formula? V square minus u square is equal to 2as. So through that, you got the velocity. Then what did we apply? Since time is involved and distance is known, use the formula s is equal to ut plus half at square for the second part of the journey. There, distance is how much? 24.5. U will be the, so initial velocity in the journey will be the final velocity of the first journey. That is substituted into how much is the time taken? 1, and then substitute everything, square on both the sides. You will get an equation, solve for h. Okay. So I can copy it. 1 minute. The final answer after you calculate should be 68.0125. You might get it because I took value of g as 10. If you take 9.8, you will get it. See, that purely depends on your teacher, okay? They are very particular, they want the exact number, then you lose marks. They're only concerned about your logic, you will get it. So that I cannot guarantee. Can we proceed? So we'll go to the last part of this chapter. So we'll go to the last part of the chapter, which is called as relative velocity. So when you discuss about relative velocity, it can take place either in one dimension or it can happen in two dimension as well. Okay. So what we need to understand is what exactly does this term relative mean? Okay. So listen to this carefully. In your lower grades, you would have learned a concept called as relative density. Right? Where did you learn this? In physics, okay. In chemistry also you have. In physics also you have in the chapter named fluid mechanics. That is gravitation chapter was there, no? There when you talk about the concept of buoyancy, you need to know what is relative density. I'll tell you what is the definition. Relative density means it is a density of substance by density of water at 4 degrees Celsius. It is the density of a substance divided by the density of water at 4 degrees Celsius. Okay. Next is you have something called as relative refractive index. So you know what is the refractive index, right? It is represented by the symbol mu, or some books refer to it as N. In your NCERT, they refer to it as N. Some books use mu. Okay. What is the refractive index? Basically, it is a ratio of speed of light in vacuum to the speed of light in a medium. Okay. Whereas if I use the word relative, then you start writing it like this: mu 2(1), right, is equal to mu 2 divided by mu 1. You write like this. Refractive index of second medium with respect to first medium. You have seen these kind of equations. No? Now, if you see, the main point is I'm not talking about density or refractive index, but I'm talking about the prefix, which is relative. So wherever you say relative, right, it is always a comparative study. So it is a comparative study. You're trying to compare a parameter of one object with respect to another object. So that depends on what is the prefix you're adding. For example, when you talk about relative density, what are you actually comparing with? Density of a substance, and you compare it with the density of water at 4 degrees Celsius. Similarly, when you talk about relative refractive index, you're trying to compare the refractive index of one medium with respect to another. So when it comes to comparison, right, the comparison can be done in two ways. Listen to this very carefully. The comparison can be done in two ways. That is like how you did here or how you are going to do here. So this I took as a case study. I tried to understand, can I draw some information out of it? I understood that it is comparison. But here the comparison is in terms of division. The other type of comparison that you can do is through difference. So give me that pen. So what I'll do is I'll take this pen and I'll take this pen. Okay. I'll give you a scale. I'll ask you to measure their lengths. You'll report an answer. Let's say the height of this is h1. The height of this is h2. Okay. Now, these two have their individual attributes associated. In the sense, this has a specific height, this has a specific height, this has its own dimension, this has its own dimension. But the only dimension I am concerned about is height. So there are two ways I can put a question. One is I'll ask you what are the individual heights. You're going to report the answer h1 and h2. What did you say? So for the one which was in my left hand, it is h1. For the one which was in my right hand, it is h2. Right, h1 and h2. The second way in which I can ask you the question is, how tall or short was the first pen compared to the second? Are you able to understand what I'm saying? So I am asking you to compare their lengths and give me the answer. If I ask you how tall is the first pen compared to second, what will you say? So you draw a line like this. You say h1 minus h2. Suppose I put the question like this. How tall is the second pen compared to first? You will take height of the second pen, subtract the height of the first pen from it. The only thing is final answer will be negative. So when it comes out to be negative, it clearly indicates that the second pen is not taller than the first one. It is shorter than the first one. So that is a meaning of the negative sign. Are you able to get some perspective out of this? Now, this is what is called as relative heights. What do I call it? Relative heights, because I'm comparing their heights using subtraction. Right? Same is the concept with relative velocity. So to put it shorter, whenever you see the word relative, you can either find the comparison between two similar quantities using division or using subtraction. So whenever you talk about relative velocity, it is all about subtraction. Meaning, I'll calculate the velocity of first object, I'll calculate the velocity of second object. So if I ask what is the velocity of first with respect to second, I will subtract one from the other. Similarly, vice versa. Okay, that is what I'm going to explain it now. Is this point clear? Right? Did you understand this example? Right. Yeah. So you do H2 minus H1 only. If the diagram is not there, you will do only H2 minus H1. You will only be concerned about what is the final answer. அதான்டா சொல்றேன் கேளு ஃபுல்லா கேளு. That is why I asked you to concentrate. நல்லா கேளு. H2 minus H1 பண்ணுவ. What did I tell after that? You will get the answer negative. And what does that negative indicate? It is shorter. So அது valid இல்லை. So அதனால நம்ம question எப்படி வேணாலும் கேட்டுப்போம். But when you do, I am focusing on what is the meaning of the negative sign.
Sir, I have a doubt.
First question is tall. In the second question, you will get the answer negative. So you will not report the answer as tall. You will say it is short by this value. So basically, what I want you to concentrate here is compare. So you are comparing the same parameter of two different objects. That is what is called as relative. But here, what I'm doing is I'm finding the relative velocity. As the name suggests, what will you compare? You will take velocity of two objects and compare the velocity of one with respect to another. Am I clear? Right? So please make a note of this.
I have a doubt.
Asking something.
Yeah, sir. For relative density, why do you divide it by H2O's density and 4?
Because that is where you have 1000. Density of water at 4 degrees Celsius is 1000 kilogram per meter cube. It's
So
a mix. So you are comparing the density of a substance with a known parameter, that 1000. Yeah. So when I talk about refractive index, no, why are you writing? If I don't use the word relative, if I ask you only what is refractive index, what will you tell me? It is the ratio of speed of light in vacuum.
Speed of light in vacuum by speed of light in vacuum.
Why are you using vacuum there? Because that is a known value to us.
Okay.
So when that word relative is not there, you will always compare it with a standard value. That is the meaning. But here, yeah, relative density has another name called as specific gravity also. Not sure if that was there or it was deleted for you. Deleted, huh? But you will learn this year. So I could have directly given you the formula, various steps actually, I'll tell you. Problems are very simple. But I want you to understand what it is. Will I proceed? Okay. So listen to this. You need to give a notation. If I write H1 minus H2, it is written as H12. So how do you read it is? Height of first object with respect to second object. Similarly, if it is H2 minus H1, you will write it as H21, meaning height of the second object with respect to the first object. Okay. So having the same context in mind, what we will concentrate upon is understanding relative velocity. It's called relative velocity. See, this concept is defined because velocity can help you to get displacement and acceleration. That is why we take velocity. Relative can be added to any term. You can talk about relative displacement. You can talk about relative acceleration. So relative is basically comparison. That's it. Okay. But this is given as a specific topic. So don't look at it like a very big concept. People get scared. There's nothing in it. It's just a comparison. So relative velocity means what? It is the velocity of one object with respect to second object. Am I clear with this? So to put it simple, if I write v21, the only thing is velocity is a vector. That point you need to be careful. So you put a bar on top of it, right? How do you read it as? Velocity vector of second with respect to 1 is equal to velocity vector of second minus the velocity vector of 1. So here, whatever is a number followed, that should be written first. After the minus, you write the second number. Am I clear with this? Right. So this is the formula, or whatever you call it. Okay, this is a mathematical expression needed for us to solve the problem. Secondly, what you need to know is velocity of the ground is considered to be 0. Velocity of ground means the place where we are standing is considered to be 0. Means if a person is standing on a ground, his velocity is considered to be 0. Okay. So when I talk about velocity of second person, for example, if I call this as V2, the actual meaning of V2 is, it is actually V2G. That is velocity of the second person with respect to ground. So what will you get? You will get velocity of second minus velocity of ground. But what is the velocity of ground? It is 0. So V2G is the same as V2. But we don't write V2G every time. You need to understand when we write V2, it is the absolute velocity. So if you compare any velocity with respect to ground, you call it as absolute value. So that is absolute velocity. If you compare the velocity of one object with respect to another, you call it as relative velocity. So the second object should not be grounded. That's it. I hope this makes sense. So this table is what you need to know to solve any problem. So make a note of it. புரியுதா? Shall I proceed? Okay. Listen. So there are some graphs which you need to know with respect to relative velocity. So if there are two objects where you have the object's velocity to be exactly the same, and you try to draw the position time graph for it. When you draw the position time graph for it, what you will have is the first line and the second line will be exactly parallel to each other, provided this is a situation where the object is not accelerating. The velocity of the first object is equal to the velocity of the second object. Both the lines will be parallel to each other. Suppose velocity of second is greater than velocity of one, then the second line will be slightly at a greater inclination compared to the inclination made by the line from the first object. Because for a position time graph, what is slope? For a position time graph, what is slope? Slope is velocity. So if I say velocity of second object is greater than the velocity of the first object, then slope of the second object should be greater than the slope of the first object. That is why this makes more angle compared to the second part. Right? Similarly, if the velocity of the second is less than the velocity of one, then what will happen is first object will have a greater slope. First object will have a greater slope compared to the second object. So in this scenario, there is a possibility where both the objects will meet. Whereas in this case, they will not meet. Why will they not meet? Because the lines are getting diverged. Whereas here the lines are getting converged. So they will meet. Are you able to understand? So this can be one of the questions that they will ask you. What they can do is they can give you this graph and ask you to describe the situation. So just to conclude, what is the situation? This is the position time graph when the velocity of the first and the velocity of the second are same. What about this? This is the situation when the velocity of second is greater than 1. What about this? This is when the velocity of second is lesser than 1. So in this scenario, they will meet. Clear? So theoretically, we are done with this chapter.
Sir, I don't understand the
Which one,
V2 is lesser than V1.
A third one.
Yes, sir.
See, there are no. Did you understand the concept of slope?
Yes, sir.
When that is a scenario, observe. If I draw a line here and if I draw a line here, right? Out of the, so I'll call this as the first line, I'm converting it to red. Okay, second line, let it be in pink itself. So compared to the red line and the pink line, which one has greater slope?
The first one.
So theta 1 is greater than theta 2. Am I right?
Yes, sir.
Okay. When that is a scenario, you draw the graph, then isn't there a possibility, the graphically, is it not representing that they both can meet at a particular point?
Oh, okay.
That is what I meant. That's actually mathematics, nothing to do with physics.
Okay, sir.
Yeah. Shall I proceed? Okay. Now you see how simple the problems are. So listen, let's do problems based on relative velocity. This is one-dimensional relative velocity. Okay. So first example, a car A moving at a speed of 10 meters per second on a straight road is ahead of car B moving in the same direction at a speed of 6 meters per second. Find the velocity of A relative to B. Meaning the question is, what is the velocity of A with respect to B? What is it going to be? It is velocity of A minus velocity of B. So put an arrow mark on top of it because it's a vector quantity. Now take the data. What is the velocity of car A? It is 10 meters per second. What is the velocity of car B? It is 6 meters per second. So first I wrote the magnitude part. Now again, I'm reading the question. If you observe, they both are moving in the same direction. So if you take the velocity of A to be positive, B will also be positive. They told same direction. They didn't tell whether it is right or wrong. I mean, right or left, right? So find the velocity of A with respect to B. Take these values and substitute it here. 10 minus 6, answer will be 4 meters per second. That's it. Yeah, why? First, let me explain what is the meaning of this. So the meaning of this 4 meters per second is, since you did the comparison of A with respect to B, you're trying to say that car A is having 4 meters per second more velocity compared to car B. I hope you're able to understand this point. Now, when I find vice versa, see, observe. If I do VBA, it is going to be velocity of B minus velocity of A. So, what is the velocity of B? 6 minus what is the velocity of 8 is 10. You get the answer as minus 4 meter per second. I hope you're able to understand the meaning of minus. Minus means the second car is slower compared to the first car. That's obvious because we have the numbers here, right? So that is the meaning. So all that you need to report is VAB is 4 meter per second and VBA is minus 4 meter per second. That's it. Right. Should I proceed? So the second example is two parallel rail tracks run north-south. Okay. So there is a railway track which is running like this in this direction. It is extended. So train A moves north with the speed of, so train A is moving with a speed of 54 kmph. And train B moves south. So velocity of B is 90 kmph. Okay. First question. What is the relative velocity of B with respect to A? First thing, since velocity is a vector quantity, here you need to observe that they both are in opposite direction. Okay. So if I take this to be positive, downward will be negative. So what is the question? You need to find the velocity of B with respect to A. It is going to be velocity of B minus velocity of A. So what is the velocity of B? It is minus 90 minus is the formula. What is the velocity of A? It is going to be 54. So how much will the answer be? Minus 144 kilometer per hour. So what is the meaning of this minus sign? It's not slow. You can say whether it is fast or slow only when the objects are moving in the same direction. Here, what will happen is, see, I just want to ask this. You people travel in train? Only flight? Train going? Okay. So when you go on a train, have you ever observed, let's say your train has stopped in a particular station and there is a train which is moving from the opposite side. Okay. So there are two situations. You're stationary. Let's say there is a train which is coming in the opposite direction. What do you generally feel? You feel as if you're moving and you feel as if you're traveling in the first place. You feel that, right? Right? Why is it happening? Because it is a relative value. It is a relative value. See, had this train been stationary, had it been 0, then what will the answer be? For example, the same question, velocity of A was 0. That's the situation I'm trying to describe. Then velocity of B with respect to A will be minus 90. Meaning of it is, you feel as if you're stationary only. The meaning of velocity of B with respect to A means for the person who is actually sitting in that moving train, no, he will feel as if he is moving in the backward direction with 90 kilometers per hour. That's what happens. Okay. So he will feel as, sorry, not he will feel that he will feel as if your train is moving backwards with the speed of 90 kilometers per hour, which is not happening. In this case, whenever they are in opposite direction, it doesn't mean slower or faster. It is a feeling. Like whenever you talk about same direction, then you can talk about slower or faster. In this case, I cannot say which one is slower and which one is faster. The ultimate thing is I need the absolute numbers for me to speak which is slower and which is faster. So here the minus sign indicates the direction. Are you able to understand? Similarly, if I calculate the relative velocity of ground with respect to B. So relative velocity of ground with respect to B means it is a velocity of ground minus velocity of B. So what is the velocity of ground? What is the velocity of B? Minus 90. So answer will be 90 kilometer per hour, meaning you are on this side. See, you are stationary here. There is a train B which is moving here. There is another person on the ground standing on the other side. So when that person standing on the ground is observing how the train B is moving, according to him, it is moving at the same speed of 90 kilometer per hour because he is not moving, he is not going to sense anything. Are you able to understand? So that's what happens. What is this monkey? Okay, velocity of monkey. This is actually a textbook question only. Velocity of monkey running on the roof of train A against its motion with a velocity of 18 km per hour with respect to train A as observed by a man standing on the ground. So they want us to find the absolute velocity of the monkey. There is a monkey which is running on the top of train A in which direction? In the direction opposite to the motion of train A, meaning it is running in the south direction. But that is the case, but it is moving with a velocity of how much value? 18 km per hour, but that is not absolute value, it is a relative value. Read the question carefully. It is moving with a velocity of 18 km per hour with respect to train A. So velocity of monkey with respect to train A is 18. But what do they want? They want the absolute velocity of the monkey. இதுக்கு தான் செல்ஃபி எடுத்து ஓடாதீங்கன்றது. சரி, solve this. First copy this, then I'll rub this and solve the third part. Done? It's up to you. You want to take this direction as positive, take that as negative. But only thing is, you need to have clarity of this positive and negative sign. Shall I proceed? Shall we try the third one? Okay, listen. So listen. So there is a monkey running in this direction. So velocity of monkey with respect to A is how much? 18. Okay, it is going to be 18 km per hour. Now velocity of the monkey observed by a man standing on the ground means they are asking what is the value of Vm. Okay. So first of all, tell me, how can I write this VMA as? I can write it as Vm minus VA. So what is the velocity of monkey with respect to ground? It is going to be 18. So what is the velocity of monkey? Minus, what is the velocity of A? So this will go to the other side. Velocity of the monkey will be 54 plus 18, which is going to be 72 kilometer per hour, which is basically 4 meters per second. Okay. So velocity of monkey or running on the that's right. Train would speed அதிகமா இருக்கா? That will appear. That's what I told you, no? It is a relate. Oh, it is absolute value. இல்ல, but இங்க வந்து relative value தான் 18 கொடுத்திருக்கான் because it's moving
Sir.
against, no? அதை பத்தி நம்மளுக்கு என்ன கவலை இருக்கு? This is only at a particular scenario where this was observed. First of all, அங்க 18 எவன் calculate பண்ணி சொன்னா? ஸ்பீடோமீட்டர் ஏதாவது வச்சிருக்காங்களா? நான் monkey-க்கு.
Sir, if it's against its motion, won't it be? Is it not opposite to the direction of the train?
Which one?
The velocity of monkey running on the roof.
So
of
let
the
me
train.
read the question. Velocity of a monkey running on the roof of a train A against its motion. Okay.
Sir, I'm asking if it's in the opposite direction of where the train is moving.
Yeah, that should be the case, but let me check. So it is VMA only, Noda. VMA is equal to VM minus VA. Correct? And I'm not sure if I missed it. Answer வந்து என்ன கொடுத்திருக்கா? What is the value given here? Velocity of the monkey VM னு எடுத்துக்கோ. Relative velocity வந்து it's more only. But yeah, one point I missed is.
Sir, it will be minus 18, right?
I should have taken minus 18 here. That's what I missed. That's what I was thinking. See, this direction I forgot to write actually. Thing is, this direction is there. No, it is actually velocity of monkey with respect to A. That was the point. So it is minus 18 is equal to VM minus 15. So when it comes to the other side, 54. But even then, 36 is how much? 36 into 5 by 18. 10 were the. That sounds. Yeah, it should be. Yeah, it came out to be less, no? So it is 54 minus 18. It will come out to be 36. So 36, yeah, 10 meters. So this minus sign is what I missed. Opposite direction. I forgot to write the minus sign. I made a mistake there. And this direction is VMA, not VM, actually. So what is the meaning of this 36? But 1 minute, velocity of monkey. Here, what they are trying to say is with the velocity of this with respect to A as observed by a man standing on the ground. Okay. So it is 36. Clear with this? Can you try this one? So two trains, 120 meter and 80 meter in length, are running in opposite directions with velocities of 42 km per hour and 30 km per hour. In what time will they cross each other? So you need to take the length into consideration. No?
So is it 10 seconds?
அப்படி பண்றதுக்கு பதிலா you can solve the problem with relative itself. I'll tell you. But
Sir,
you try. How did you get
I-
10? 10 is
Sir.
correct, but how did you get 10? I told you one concept in the beginning. Relative is not restricted only to velocity. Relative is restricted to distances and acceleration as well. Then if that is the case, how will you solve? But so tell me one thing. Observe. Let's say this is train A, which is having a length of 120 meters. Let's assume that it is traveling in this direction. They told opposite, they didn't tell which one is in which direction. Let's say the second one is starting here and its length is 80 meters. This is traveling in this direction. So what is the speed of this? This is 42 and here it is 30. Remember, they are in kilometer per hour. Okay. So whenever you have these kind of problems and they're asking the time that you need to calculate, no, you can still use the formula S is equal to ut plus half at square. But the only difference is you add a prefix called as relative, relative, relative. So what I'm trying to say is relative displacement is equal to relative initial velocity into time plus half into relative acceleration into time square. Okay. So in this problem, if you observe, the acceleration is 0. They're not accelerating because they've given only the velocities. Okay. If it is accelerating, they'll give you. So acceleration is 0. So what is the relative displacement of both? It is not 120 minus 80. Suppose if I keep this at rest, okay, if I keep this 80 meter at rest, so how much is the distance it is covering? It is covering 120 meter. See, it is starting here. So it is covering 120 meter. For the last compartment to come out, how much is the extra distance it needs to cover? 80. So how much is the total distance it is covering? It is covering 200. I repeated, starting from here, it is traveling 120. But when it has completed 120, 40 will be outside. See, there will be a particular instance where this 120 is like this. Meaning the last compartment is coinciding with the last compartment, with the first compartment of the second train. But when can you say the journey is completed according to this question? When will they cross each other? No. Crossing each other means the last compartment of this and last compartment of this, when are they coinciding? The second after that is what they're asking. Meaning, what I did is in this problem, I assumed that this is at rest. Okay. Well, I'll tell you why I assumed at rest. I'll come to that point. But as of now, remember, I assumed it to be at rest. So how much is the distance it has to cover for that scenario to occur? Means the last compartments to coincide. Yes. Because in this scenario, what will happen? It has covered only 40 meters. But for the last compartment to come here, it should cover 120 more. So 120 plus 80 is the relative displacement. It is going to be 200 is equal to, what is the relative velocity? One is 42 and the other is 30. They both are in opposite direction. Whenever they are in opposite direction, velocities get added or subtracted. By now you would have seen it. We solve two problems. If they were in the same direction, they get subtracted. If they're in opposite direction, they get added. So here I will write it as 72 kilometer per hour. So kilometer per hour means into 5 divided by 18. In this problem, I need to do this because train's length is in terms of meter, velocity is in terms of kilometer into time. So this will cancel this 4 times. 5 into 4 is 20. So 20 will cancel this 10 times. So t is equal to 10 seconds. So it takes 10 seconds for each of them to cross the other. Did you understand this problem?
Sir,
Tell me.
if the question was when they meet each other, like not completely cross, but they just meet, then what would be the length?
When they
Just meet each other.
meet each other, na zero. I'll answer illi. I'll be able to tell when they meet each other only when I know how much is the initial distance between them.
Okay, so now we've assumed that only one is moving in one
Yeah, now
direction.
I'm assuming that the initial distance between them is zero.
Okay, okay.
Because the question is in what time they will cross each other. That's what they ask, no?
Okay, okay.
Yeah. So you will think about crossing each other only when they meet first. Means the first compartment of the first train should coincide with the first compartment of the second train. That is the engine basically.
Yes, yes.
Yeah. Did you understand how to solve this kind of problem? Okay. So listen, what did I do here? I told you one thing. I assumed one of them to be at rest. So what I actually did is, I'll tell you, I'll explain the problem. See, that's what they wrote, relative velocity of one train with respect to other. They use the direct formula 20. Total distance traveled by each train to cross is 200 meters. But I hope you would have understood why the 200. So what I actually did in this problem is, this is, let's assume train A, and let me assume this to be train B. Okay. So this is moving with a speed of 42 kilometer per hour. This is moving with a speed of 30 kilometer per hour. When I wrote relative, I told one of them is at rest. Which one did I consider to be at rest? B to be at rest. Meaning, if I want this B to come to rest, then what should be the velocity that I need to give to it in the opposite direction? I need to give it 30 kilometer per hour. So minus is obvious. It is exactly in the opposite direction. Now what is happening is, if I take this 30 kilometer per hour in the opposite direction, right, then this 42 and 30 are getting added. So what I did is, I took all of its velocity and gave it to A. That is the meaning actually. So when can I bring it to rest is, I take this 30 and give it to A so that becomes the absolute value. So to put it simple, right, if you look at the algorithm of how you are supposed to solve these kind of problems, whenever you have a question of when will one cross another, you will have some problems where there is a person running, when will the first person be able to catch the second and all those things. At that time, if both of them are running, try to bring one of them to rest. So if you need to bring one of them to rest, what is that you need to do? Whichever object you're trying to bring to rest, consider its velocity to be exactly in the opposite direction of initial value, and then start solving the problem. So that it becomes simple, or else what will happen is you will get confused with the directions. Is that point clear? Right? So this is all about the concept of relative velocity. Right. So with this, the chapter is over. So motion in one dimension is completed. And the remaining problems, you need to solve it from your this one, study material. Okay, that will be uploaded and you need to solve it. Thing is, next class, what I'm going to do, I'll give you a heads up. I'm going to start with motion in 2 dimension. That is motion in a plane. But for this, you see, I have already covered the concept of vectors. Okay. So this is already over, which I dealt it under the concept of vector algebra, which you need to go through. I'll tell you what are all the concepts that are important. Okay. First, you need to know, you need to go through the initial videos. You need to understand how a vector is different from a scalar, right? Secondly, you need to understand how to represent a vector. So representation of a vector is what you need to know. Third one is about orthogonal unit vectors. So these three concepts, if you know, tomorrow's class, what I will do is I will start with one of the concepts called as resolution of vectors. And from there, I will discuss another topic called as projectile motion. So basically, projectile motion is very simple. If you think of we discussed some problems which were traveling under the influence of gravity, right? Which I told you free fall, right? So in that case, what did we do? You took an object, you gave the velocity in the linear direction. You either threw it upwards or directly downwards. Whereas in the case of projectile motion, what you will do is you will throw at a particular angle. So when you throw it at a particular angle, unlike the scenario that we discussed in the case of the vertical motion, here what will happen is the object will travel in this kind of a path. Okay. And this path is called as, this you already know. Where did you hear about parabola? In your 10th grade, quadratic equations. So what kind of a parabola is this? Downward or upward? So when will you get the downward parabola? When the coefficient of x square is. So this is what we are going to see. So for the basics that are needed for this is some idea of what is a vector and everything. But whatever is needed for me to start with this, I'll explain. That is the resolution of vectors I'll start with tomorrow. And I'll explain about how to handle two-dimensional, the motion in 2 dimension with the help of equations of motion. So all that I will do is, you saw, no? I wrote a suffix here. What is that I wrote? I use the word. So I'll be using the same equation. V square minus u square is equal to s. V is equal to u plus at. S is equal to u. Same formula. Only difference is all that we dealt here is 1 dimension. That is why I didn't write any suffix there or subscript, sorry. So what I'll be doing in tomorrow's classes, I will write this equation separately for x-axis, separately for y-axis, and then combine both. Okay, it is not actually tough at all. It is easy. Okay, so go through that and come. Am I clear? And next week, you remember about the test, right? This chapter, motion in 1 dimension. Those are online, we'll wind up.
Thank you, sir. Thank you, sir.